Again, not the exact same problem from the notes, but should give you the same idea. We're trying to decide if this sequence's limit is equal to 7. The way I'd write this as a limit statement is the limit as n goes to infinity of 7n plus 1 over n minus 5 is equal to 7. And the way we read this is to say as n gets huge, does this expression basically become 7? That's the idea of the limit. And that means that at some point, for n's and all the n's past it, infinite number of n's past it, does this get arbitrarily close to 7? I don't know. Let's find out. So I'll take this sequence, 7n plus 1 over n minus 5, and I want to know when it's between 7 minus a tiny bit and 7 plus a tiny bit. How tiny? Epsilon tiny. Smaller than small. Whatever number you just thought of that's super small, take half of that number, and it's actually less than that. I'm being funny. So we're not really. So we're going to go ahead and solve this by setting up two different inequalities. One will look like this, and the other one looks like this. And I'm worried that I did not give myself enough room for all the algebra, so I may do a pause and delete. But let's look at this side. I'll do this in beautiful green. 7 minus epsilon is less than 7n plus 1 all over n minus 5. N is gigantically positive, so if I subtract 5, still positive. And 2, I'll multiply both sides by n minus 5. Do a little foiling magic. Awkward. And then we'll see what happens. It turns out that if I subtract 7n from both sides, these will cancel each other out. I like to keep the n positive, and this epsilon's positive, so this by subtracting it, I don't like that. So I'm going to put all this stuff on the other side. And then I'll subtract this 1 from both sides. So I'll end up with a negative 36 plus 5 epsilon less than epsilon n. I'll divide through by epsilon. Giving me n is more than negative 36 plus 5 epsilon over epsilon. Okay, that's a good sign. So now, let's get rid of all this work. Let's take this little fella, move him over here. Whoopsie doodle. And we'll solve this part of things, and we'll do that in beautiful light blue. 7n plus 1 less than. Foil all this fun stuff out. And then I do want to get all the n's to one side. I know that these will knock each other out. This is going to be positive. It stays positive. I'll leave it where it is. So I'll move this guy and this guy to the other side. If I add 35, I get a 36. Plus a 5 epsilon less than epsilon n. Divide by epsilon, which is positive. And that gives me n more than 36 plus 5 epsilon over epsilon. So as long as n is more than this, which is going to be maybe a huge positive number, and as long as n is more than this, which is a huge negative number, then this is going to be really, really close to 7. Now, since there are an infinite number of numbers that are both more than this and more than this, at some point, this point, the terms of this sequence get really close to 7 and they stay really close to 7. So I can say with confidence that the limit as n approaches infinity of 7n plus 1 over n minus 5 does in fact, well, that's not how you say equals, does in fact equal 7. Because at some point, this point, if you tell me the epsilon, I can tell you the value for n where all the n's past that number are that close to that number and they stay that close. I hope. If it's not, most of it's algebra. If the algebra makes sense, great. If you need help with the theory, we can talk about it over office hours. And otherwise, I'll see you guys in class. Good luck.